Okay, welcome back. We're gonna do the other type of distance, rate, time problem. In this case, we got number 6 on the sheet I'm giving out in class. I'm calling this the hither and thither problem. Hither and thither means this way and that, going to and fro, going somewhere and coming back. Think of them as round trip problems. Sometimes they go the exact same distance. Sometimes they may have different distances involved. But generally speaking, you're going to have a trip in which going one way you are fighting against a current or a wind speed or a horde of zombies walking the other way. In the other direction, you're going to be buffeted along and aided by the wind or the current or the horde of zombies marching along in the same direction you're going. So let's look at number 6. Now, of course, in all cases, I want you to read the problem, see if you can set it up before I walk it through, and pause the video. Assuming you paused the video and you came back, here we go. I'll work this out for you. So we have your McMansion houseboat can make it up a 108-mile part of a river in 9 hours. So we have a distance and we have a time. So upstream, so we have an upstream bit of information. Upstream, we have a distance of 108 miles. We have a time of 9 hours. We do not have a rate yet. Okay, we also have a downstream part of this, and the distance is the same. So we go down the same distance, 108 miles. Okay, we've got 108 miles, but the time is not 9 hours this time, it's 6 hours. So going downstream, we were clearly helped. We got there faster. Going upstream, it took more time. So something is going on with rates. So, of course, we don't have a rate. So we have rate is missing. Okay. Let me copy this in here. So this is going to be a little piece of information. You could easily do this as a table as well as this. This could be set up that way because of time efficiency with word problem with typing in Google Docs. I'm doing it this way. So we have a rate going upstream. So we want to know our speed in still water. We also want to know our river's current. So those are the two missing pieces of information. So going upstream, there's the speed your McMansion houseboat contributes. So I'm going to call that the boat speed for B. Okay, and then going upstream, there's the river's current, and we got to think, what is the river's current doing to the boat speed? It's fighting against it, so we subtract it. Going downstream, though, we have our boat speed, and we have our current speed, but they're combined, they're added together. So that's your rate. Your rate is this combined rate. So now we can create our equations. So pause and see if you can create the equations if you haven't done so yet. If you have, that's fine. You can keep going. And I'm going to set up my upstream equation. My upstream equation is based on distance equals rate times time. So that's going to be 108 miles equals my rate of B minus C times my time. I can put this time here. I can put it on the other side of the parentheses because I'm doing the distance equals rate times time structure. I'm going to go ahead and do it in that order. My downstream equation is also a distance equals rate times time situation. So I've once again 108 miles equals my rate of B plus C, boat speed plus current speed, times a time of 6 hours. And now I have my two equations. And I'm going to work them out really quickly. I invite you to pause to see if you can sort it out yourself. And if you paused and came back, welcome back. I'm going to go ahead and set these up next to each other. get rid of this extra stuff. The first thing I need to do, I do need to simplify these equations. I have two ways I could simplify it. One is I could distribute 9 across b minus c and get 9b minus 9c. Or I could distribute 6 times b and c and get 6b plus 6c. Or, in this case, it won't always work out this way, but I notice 108 is a multiple of 9, and it's also a multiple of 6, because 1 plus 0 plus 8 equals 9, and it's an even number. The digits add up to 9, then the number is multiple of 9. If the digits add up to a multiple of 3, which 9 is, and it's even, then you have 3 and 2 as factors. So 3 and 2 as factors means you have a multiple of 6. So now I sort of walked through how I know it's divisible by 9 and divisible by 6. I'm going to take advantage of that. I'm going to divide both sides by 9. So if I divide both sides by 9, 108 divided by 9 is going to be 11. And that's going to equal b minus c, because 9 divided by 9 is nothing. If I take the other one, I'm going to divide both sides by 6. Okay, I can get 6 into 10 once. That leaves me 4. So that's 48. So that becomes 1, and then 6 goes into 48 8 times. So I've got an 18 there. And then 18 equals b plus c. So now I've got two equations that are a little easier for using the elimination method, though I could certainly use the substitution method with these. I'm going to subtract them if I want to get rid of b, or add them if I want to get rid of c. I will start by subtracting them. 18 minus 11 is 7, and that's going to equal to c. So my current is going to be half of 7, so divide both sides by 2, and I get 3.5 equals my current. And then I'm going to do the same thing. I'm going to do elimination only. Now I'm going to aim to get rid of C, and so I'm going to add them together. So 18 plus 11, when I add them together, is going to get me 29. And if I add the b plus b is 2b, and so now I can work out my boat speed. My boat speed is going to be 29, so it's going to be half of 29, which is going to be 15.5. Now, I think I might have made a mistake on this. I'm going to double check my calculations. I do have an answer key for this, and I'm going to go down and quickly look at my answer key. Now, my answer key says 15 and 3, so I'm going to go back and look through and see if I made some sort of mistake in this. It's possible I made a mistake here. It's possible I made my mistake in my setup. So I'm going to confirm that 108 divided by 9 is 11. No, it's 12. That's my mistake. Okay, so let's go back. This becomes 12. This becomes 12, which means this is 30, which means this is 15. Okay, and when I subtracted them, 18 minus 12 is actually 6. So that's not 3.5, it's 3. So mistakes happen, and so here we go. We've got a current, and I could have discovered that mistake by going and plugging in my numbers into my equation. I would have discovered the error once I did that. But so I have a current speed of 3, and I have a boat speed of 15. So there you have the solution, complete with the bloopers from Mr. Ward. All right, so go ahead and try the other equations. The answer key is on the back of the sheet for you. So thanks for watching.